Hello, everyone, and welcome to our webinar today, AI RAN Opportunities and Considerations for Telcos, which we're running in partnership with Red Hat. So big thank you to them. And thank you for joining. If you're in the UK, I know it is sunny and bright, and the temptation to go out and suntan is always there. So we're grateful that you're joining us. I'll quickly run through some housekeeping and a few introductions. Then I'll hand over to Gabby for a presentation before Ignacio will pick up with a presentation from Red Hat. And then we'll have about half an hour to have a panel discussion and Q&A. So do encourage you to ask questions. And if we just go on to the next slide, I'll show you how you do that. You are in listen-only mode, so you're muted. But if you do want to contact us, there are ability to ask questions and comments, and we can pick those up. Again, I've got some fiendishly difficult questions here to ask the panelists, but I'm sure we'd all love to hear your questions, comments, views, and so do put them into the Q&A there. We'll answer as many as we can. If we can't get to anybody, we will answer those in writing and get those back to you. And just to let you know that all slides and a recording of the session will be available, and you're free to share those with your colleagues. So, who have we got amongst us? I'm joined by my colleague Gabby, who's going to present. She's a senior consultant at SDL, and then we've got Ignacio from Red Hat, business development director in EMEA for the telco business unit, and delighted also to have Dr. Alex Jinsun Choi from SoftBank, and who's also the chairman of the AI RAN Alliance. And so he'll be able to talk about some of the activities going on in SoftBank and the role of the AI RAN Alliance. So delighted to have our speakers with us. So big thank you to them. And without further ado, ahead of schedule, I'll hand over to Gabby, who will pick up the reins.
Nice. Thank you, Chris. So before we start talking about AI RAN, we first need to take a bit of a step back and talk about RAN more generally, and most importantly, why it can no longer be managed with, why it can no longer be managed with traditional methods. So there are several reasons why radio access networks are under so much pressure today, and the most prominent one of them is the exponential growth in data demand. So mobile traffic is doubling roughly every 2 years, and this significant growth is mostly driven by things like video streaming, IoT devices, AI applications, and so on. On top of that, traffic patterns are also becoming more unpredictable. And nowadays, a sudden viral event or an unplanned emergency that happens can cause a huge network strain within minutes, which means that the old model of static network resource allocation no longer fits. Compounding this issue, the network complexity is also increasing with the introduction of new technologies like network slicing, which require dynamic and real-time decision making. Meanwhile, operating costs actually continue to rise, and managing multiple RAN sites manually is becoming too expensive and also too slow, which means that in order to scale cost effectively, RAN sites require automation. On top of that, networks now consume more energy than ever before, and the RAN actually accounts for approximately 70% of that consumption. So as energy prices fluctuate and more often increase, and sustainability regulations tighten, telcos must find ways to operate more efficiently without actually compromising user experience. At the same time, customer expectations are growing. So mobile users today usually demand ultra reliable connectivity, usually regardless of their location, which means that networks must adapt in real time to maintain that consistent quality of service that a lot of customers expect. And then finally, enterprises nowadays also want more customized and more dynamic network services, such as low latency, which is guaranteed to them. And telcos are enabled to meet that with traditional one-size-fits-all RAN architecture. So as you can see, there are many reasons, and these are by all means not exhaustive. So, there are a lot of reasons why there is a need for a new approach to RAN management, which is a bit more dynamic and more automated. So, against this challenging landscape, AI RAN promises to deliver transformative benefits across broadly four key dimensions. So, the first benefit that AI RAN is promising is optimized network performance. So, AI can anticipate and optimize network conditions more dynamically. So, for example, rather than reacting to congestion after it occurs, AI models can predict traffic surges based on historical patterns, real-time location data, and things like external signals, for example, in cases of some weather events or public transport disruptions. So networks can then proactively reallocate bandwidth, allowing them to become faster, more resilient, and way more efficient, even when user and traffic patterns are constantly changing. The second benefit AI RAN offers is enhanced user experience. So, AI driven networks can predict user needs and adjust the network to deliver more consistent and more high quality experiences. So, for instance, if a user starts a cloud gaming session, the network could detect that the traffic of the nature of the traffic is a bit more latency sensitive and then automatically prioritize it. And this capability is quite critical for emerging use cases like remote healthcare monitoring, connected cars, and smart city applications where milliseconds of delay can have very serious consequences. The third benefit of AI RAN is reduced operational costs. So, thinking about tasks that require human intervention like fault detection and troubleshooting, these can be automated and predictive maintenance algorithms can detect patterns um, that would indicate hardware failures before these even happen, which would then allow preemptive repairs that would avoid costly outages, overall reducing operational costs. And AI can also help manage energy consumption, especially during periods of low traffic. So, overall, a huge promise to reduce operational costs. And then finally, AI RAN introduces new revenue opportunities. So AI RAN can enable operators to offer more differentiated services that weren't feasible before, such as network slicing, which has very strict quality of service requirements. And then on top of that, telcos can host and monetize enterprise AI workloads locally in the RAN, which can introduce new revenue streams. So as you can see, there are several benefits that AI RAN can bring to telcos compared to traditional RAN. In terms of how AI RAN might look like in practice, we broadly see three distinct conceptual models for how AI can interact with the RAN. And each model has different implications for technology architecture, for vendor partnerships, investment strategies, and also things like operational skills required. So there are various things that telcos will need to consider when choosing how AI could be integrated into the RAN. But first, we have what is called AI for RAN. So this is all about embedding AI models into the radio signal processing layer to improve RAM performance. And the focus here is on improving several key performance indicators by using AI, so things like energy consumption, network latency, and processing capacity. So then the next scenario is called AI and RAN, and this takes things a step further by looking at the RAN as part of a larger converged infrastructure. And the vision here is having a shared platform that can orchestrate both network and enterprise AI workloads. And then finally, we have AI on RAN, which builds on the tools and capabilities developed in the first two areas. And the focus here is more about commercializing and defining new business models that will allow operators to offer new AI driven services to enterprise customers. And these are all the focus areas that AI RAN Alliance is focusing on. And I guess when we talk about AI RAN, another thing that we start thinking about is ORAN. And it is important to understand how this concept interacts with AI RAN, as there are many similarities between ORAN and AI RAN. So the first similarity is, I guess, the end goal of having more open and flexible networks. So both ORAN and AI RAN strive for flexibility and adaptability in the network. And the main goal of ORAN is to open up the RAN architecture, making it vendor agnostic and modular, and just enable the use of best of breed components and multi vendor interoperability. And AI RAN kind of builds on this modularity, aiming to bring more automation and intelligence into an open RAN ecosystem and optimize network performance and make the network more adaptive and self optimizing. The second similarity is the focus on operational efficiency and automation. So, one of ORAN's key goals is to create a more automated and self-healing network through intelligence at the RAN level. And this includes things like self-organizing networks that adjust to changing conditions in real time. And AI RAN kind of accelerates this by integrating machine learning and AI-driven automation to enhance the self-organizing functions within ORAN. However, I guess as the slide suggests, there are a few differences between the two concepts. And the first one is around technological implementation. So ORAN defines open standards and interfaces for the RAN components, which enables operators to mix and match hardware and software from different vendors. But in comparison, AI RAN doesn't necessarily require open standards for hardware. Um, and then in addition, I guess the main focus of ORAN is vendor diversity, but the main focus of AI RAN is actually creating a more intelligent network. So ORAN prioritizes creating a vendor neutral ecosystem that would allow operators to select from multiple vendors to create their RAN infrastructure. But then AI RAN prioritizes enhancing the intelligence of the network through machine learning and data driven optimizations, which can be deployed both across multi-vendor and single-vendor networks. So in short, I guess there are some similarities between ORAN and AI RAN initiatives, which are both aiming to improve the traditional RAN, and ORAN kind of is setting the foundation for AI RAN. Now, in terms of the state of the industry, I guess the momentum behind AI RAN is accelerating quite rapidly, and AI RAN has increased its relevance as a topic of strategic interest for many players in the industry. And this is best illustrated by the growth in memberships in AI RAN Alliance. So the AI RAN Alliance was launched last year at MWC and has expanded from 11 founding members to 82 member organizations, including telcos, chipset vendors, software companies, academic institutions, and startups today. So impressive growth and impressive interest from different types of companies. However, as things often happen, the adoption of AI RAN is not uniform across the globe and is driven by investment appetite, regulatory support, and existing 5G infrastructure in different regions. So, for example, if we look at North America, it is kind of at the forefront of AI RAN adoption with companies like Microsoft, Amazon, Nvidia, and T-Mobile as founding members of the AI RAN Alliance. And another thing showing commitment to advancing AI RAN in North America is the establishment of the AI RAN Innovation Center by Ericsson, T-Mobile, and Nvidia. So things have advanced there quite a lot. But then in comparison, the EMEA region is slightly behind North America in terms of adoption. So there are some European entities like Ericsson and Nokia in the AI RAN Alliance, and they are important members there. But there is a bit of a lack of telco participation in the AI RAN Alliance, and Turkcell notably is the only telco in the region that is involved in the alliance. And the innovation here is probably slower due to regulatory hurdles and slightly more fragmented market than in North America. And finally, if we look at APAC, the progress here is much more similar to North America, with South Korea and Japan leading in AI RAN developments and other APAC-based companies, Samsung and SoftBank. These companies are not only the founding members of the AI RAN Alliance, but are also spearheading innovations in AI integrated RAN solutions. And we hear about them all the time. And notably, SoftBank has recently unveiled its own AI RAN platform and orchestration capabilities. So I guess the key takeaway is that North America and APAC are a little bit further ahead than India at the moment. So All that being said, I guess we have established that there are significant benefits that AI RAN can offer. Um, but to assess that feasibility for telcos to offer AI RAN, there are three key questions that need to be addressed. So, first of all, customer demand and who will need the distributed AI computing and for which use cases particularly. So, telcos should assess potential demand across different organizations and also application scenarios, including enterprises that need secure local computing resources and use cases currently limited by throughput or energy constraints, and then just figure out what the actual customer demand is. And then, second of all, telcos should consider how the total cost of ownership for AI RAN will compare to traditional RAN solutions. So, the additional cost associated with deploying GPU-based hardware and adapting the network also for AI RAN will need to be weighed against potential revenue streams to just assess whether offering these services will be feasible for that particular telco. And finally, telcos also need to assess whether the current architecture is compatible with the AI RAN model, and telcos will need to understand whether such an architecture is feasible within their environment and also in what time frame to just remain relevant. So, yeah, answering these three key questions will help telcos prepare for the AI RAN adoption and unlock new capabilities in mobile networks. Thank you. And I can now hand over to Ignacio to deliver the Red Hat presentation.
Thanks, Gabby. So you can exactly. First of all, thank you so much for having me here. It's a pleasure, and also sharing this panel with Alex Choices even more. I am Ignacio Gonzalez. I am part of the Red Hat Telco Center of Excellence. I am responsible for the mobile networks opportunities across EMEA region, and I want to share with you today just a few takeaways of what we are seeing from Red Hat point of view when it comes to talk about telco and AI and run and AI. So let's go to the next slide, please. I think it's clear that AI and the machine learning ecosystem is complex. The volumes of data are growing, technologies are rapidly evolving, the vendor landscape is constantly changing. There's no one single vendor that they can provide everything you need. AI initiatives needs to show tangible business value, and operationalizing AI is a challenging process, right? What we have seen in the past in 2023, 2024 is that telcos have AI. They were doing what I can call uncoordinated initiatives with no clear AI strategy or a central leadership. It's just about get dirty on checking what they can get from AI. And when I talk about AI, I'm talking about more about Gen AI, because AI and machine learning, they have been used by telcos for a while. In 2025, right now, we are seeing an evolution towards this opportunistic AI, which is building an AI central function or a center of excellence or a single group coordinating the whole group of AI work streams. And they try to derive more consistent practices and use cases in production. And what we are expecting in 2026, 2027 is that the telco organizations will achieve what we can call AI alignment. It's based on productivity and revenue focus. And we will see the first implementation of the agentic AI functions, generally speaking. Let's go to the next slide, please. Second idea, or the second message that I want to share is Kubernetes is a full platform for AI. Kubernetes efficiently managed and scales AI workloads across clusters, can handle GPU and distributed training. Also, it can offer seamless portability across cloud and on-prem environments, and they can support all major AI frameworks. Also, by using containers, it can ensure isolation, which is very important, reproducibility, version control for experiments and models. And also, the consistent API provided by Kubernetes can simplify the whole process. Also, I want to remind you what we announced in KubeCon in London the first week of April, which is the Kubernetes Generative AI Inference Aware. Red Hat, Google, and ByteDance have added new features to Kubernetes that can improve how it handles AI models inference, making load balancing, scaling, and performance better for large language models. Okay, next slide, please. I'm not going to spend much time talking about the AI Alliance. Having here Alex Choi. So click again, Gabby, sorry. What I want to be focused is in what Red Hat is doing as part of the AI RAN Alliance. And what we are doing is we focus on the AI and RAN working group. This group is dedicated to exploring the concurrent utilization of converged compute and communication infrastructure to run both RAN applications and artificial intelligence workloads. The integration aims to enhance platform utilization, of course, and also, as Gaby was mentioning, unlock new monetization opportunities for network operators. There are three main objectives as part of this group. The first one is resource optimization. What we try to do is effectively sharing resources between RAN and AI applications to maximize the infrastructure utilization, right? Because sometimes we can notice that the RAN infrastructure is only used by RAN, but most of the time it's not used. So how we can get from that? Multi-tenancy, which is a very interesting concept, right? It's about supporting multiple applications on a shared infrastructure in order to enable diverse services to coexist, but most importantly, without interference, right? And the third one is service quality and security. It's about maintaining high standards of service quality and also ensuring robust security measures. Because at the same time, both applications and resources have to be shared. Okay, next slide. And again, I'm going to go very quick because I think during the panel we can talk about this, which is ATRUST. It was announced in November by SoftBank. So I'm not going to spend much time there, but it was a joint effort coordinated by SoftBank together with NVIDIA. We have also Fujitsu, Micro, and Red Hat. And what is ATRUST? ATRUST is a converged carrier-grade solution, which is based on the AI RAN concept, as I mentioned before. When you can host both applications, AI and RAN, on the same computing platform supported by GPU-based infrastructure. The solution provides carrier-grade RAN with a high capacity, performance, and quality, but it also enables concurrent and efficient operations for the AI application, and this is very important. What also is very important, if we go to the next slide, please, Gabby, you click another one, is the orchestrator. The orchestrator that SoftBank created is very important. Why? Because implementing this AI RAN involves running both AI and RAN applications on a shared virtualized infrastructure. And this requires careful resource optimization. What SoftBank has developed is an orchestrator to manage this infrastructure, enabling faster data processing, real-time optimization, and improve automation and security thanks to different components. And one of the components related to the virtual platform is obviously Red Hat. Since AI and RAN workloads has different requirements, it's very important that the orchestrator can allow customized controls to meet their specific needs, right? And this is very important. That's the reason why we create this joint team between SoftBank and Red Hat to improve the coordination between the orchestrator and the virtualized infrastructure. This is very important. And if you click again, Gabby, I'm going to give you one example about what you can achieve here. Again, we can discuss the panel, but the idea is how you can get the most of the infrastructure and dynamically allocate the platform, the infrastructure, the vertical infrastructure that you have there, or the virtualized infrastructure that you have there, based on the need, based on traffic demand or customer needs. What we are seeing is how we can allocate it at the beginning when we have the big time for the RAN, the majority of the resources to the RAN. But while we are seeing that the RAN traffic is going down, the idea is that this orchestrator can dynamically allocate this capacity that now is not used to other applications. And this case is the AI edge applications that SoftBank launched there. And this is very important because at the end of the day, it's going to help to improve the return of the investment. The infrastructure is fully shared and it's not only allocated in silos just for one single technology as it could be RAN. Okay, so let's go to the next slide, which is going to be my final slide. And I'm trying to answer here. Many people ask me, what is the role of Red Hat when it comes to AI? And here I want to share with you our portfolio strategy based on 4 pillars. I'm going to go very quick. The first pillar is about the AI models, and it's based on Red Hat Enterprise Linux AI, which gives telco the availability to use their data and their knowledge to produce models meant to meet their needs of their business. At the end of the day, what we want to do here is, and telcos are doing is, you need to have language models that they can be customized for telco. They have to be maybe smaller than others. They have to use your own data, etc., etc. We help you to build these models. The second pillar is what we call the AI. And OpenShift AI allows operators to build, deploy, scale, lifecycle, and monitor all the different models in a hybrid data platform. Doesn't matter if this model is coming from Rel AI or it's coming from a partner, or as I mentioned before, it's a model built by itself. OpenShift AI gives the customer the availability to consistently put models into production and run them at scale. The third pillar is our AI-enabled portfolio, which means it's about infusing AI into the existing Red Hat portfolio to improve user productivity and increase product adoption. The initiative is called Lightspeed. What we make the experience of operating with Red Hat platforms easier and more efficient. And our final pillar is the AI-enabled applications, which try to empower different application developers and companies to accelerate the deployment and development of new applications, AI applications that can be used, let's say, by the telco. So in a nutshell, Red Hat AI strategy brings together the power of open source, the flexibility of open hybrid cloud, and the experience of working with our customers on the evolution of a telco AI. That's all what I want to you, and I'm really looking forward to joining at the panel.
Brilliant. Thank you so much, Ignacio. Let's kick off the panel. We're very lucky to have Dr. Alex with us, and I know it's late in Tokyo, in Japan at the moment, and really appreciate you staying late up in the evening. Perhaps you could introduce yourself and talk a little bit about your role at SoftBank and then within the AI RAN Alliance.
Sure. Yeah. First of all, thank you for having me. I'm Alex Jinsung Choi. I'm working at the SoftBank Japan as a principal fellow. Before I joined the SoftBank, I worked at the Deutsche Telekom in Germany for about 7 years, and before I worked for the SK Telecom as a chief technology officer. So my primary responsibility has been the chief technology officer, and at the SoftBank, I'm also chairing the AI RAN Alliance, which, is relatively new compared to my previous alliance, which is the O-RAN Alliance. So I was chairing the O-RAN Alliance, and also I am the founding chairman of the TIP Telecom Infra project. So I have a very specific, unique career experiences running, managing, and orchestrating all for the alliances in the telco industry. So regarding the AI RAN, alliances, so let me give you a just very brief introduction who we are, and what we are doing. So especially compared to the O-RAN Alliance. So AI RAN Alliance is a global industry initiative launched, as Gaby nicely mentioned, last year at Mobile World Congress. We just celebrated our first anniversary at the Mobile World Congress this year. So it's still very young, just 1 year old. And the aim is to accelerate the integration of AI, machine learning into the radio access network, and bringing key industry stakeholders, operator, network vendors, and AI technology leaders and cloud technology leaders like Red Hat and cloud providers, Microsoft, and even academia to foster collaboration and develop real-world AI RAN use cases, and most importantly, to drive the evolution toward the AI native mobile network. And unlike other standard bodies, notably 3GPP and O-RAN Alliance, our AI RAN Alliance, we are not SDO, we are not standard bodies. We are focusing on pre-standardization or post-standardization. So mainly centered around open innovation and execution and delivering the blueprints for the key use cases. So we are enabling faster prototyping and blueprint developments and ecosystem alignment through its working group, AI for RAN, AI NRAN, and AI on RAN. And additionally, we launched the two additional task group. One is data for AI, and the other one is test and methodologies. So we are addressing, optimizing, converging, monetizing of AI and RAN workloads, laying the foundations for the future. And therefore, our alliance, we serve as a catalyst for intelligent, autonomous, and future-proof, and etc. Yeah.
Thank you. Thanks for the introduction. That was very, very useful. I mean, maybe if we start with the big picture, we've got quite a lot of very specific questions. We'll get on to it. If we don't, as I say, we'll answer them afterwards. If we start with the big picture, if we go back to 2002, 2003, where the mobile connectivity and the internet was kind of exploding, there have been many promises since then of growth initiatives. Some of them standards based, some of them standards bodies and industry bodies got involved with, and very few of them have really resulted in the kind of new revenues. And we've seen probably, the industry has grown, but less in the last few years. But it's probably fair to say it's become commoditized a little bit more around pipes, dumb pipes, and then now increasingly smart pipes with the ability through 5G to slice and offer network APIs and so on. How important do you think AI RAN is for the future success of the telecoms industry in terms of getting back on a growth path? Maybe if I start with you, Alex, you're living this very clearly through both SoftBank and the AI RAN Alliance. And just to get a sense of how important you think this could be.
Yeah, sure. I mean, I would say nothing's wrong with our industry. I mean, we have an issue, of course, today. But since the inception of digital mobile technologies, our industry and market has been growing exponentially. So we have to be very proud of what we collectively achieved at the scale, at dramatic scale. And maybe this is one of the reasons why we are not being so successful in other attempt to create a new business model or dual revenue stream, because the running business is is so successful, so it's just overshadowed the new business model. Now we just started to see the whole market revenue profit all saturated. So even the vendor ecosystem is saturated. So now it's time we need to revisit all our value propositions and then think about what should be changed or what should be built to be able to address such kind of key issues, market issue, saturations, and the decoupling between the rapid growth versus increasing TCO. So the gap, this gap is something that we have to get rid of before it's too late. So in that sense, AI RAN, I believe, is a very timely and essential and fundamental shift so that we can move on to the next, how can I say, the whole industry phase. So why is it important? Because AI RAN, we are reinventing, reinventing the existing radio access network, which is the major part of the mobile connectivity. So we are focusing on RAN. So AI RAN is built from the ground up to be AI native. So which means intelligence isn't just an add-on. It is deeply embedded in the network control loop. That's the big paradigm shift. And it's important to understand what would be the key characteristics that make AI RAN is really essential, unleashing and generating new rep streams. Number one, let me brief describe 5 key characteristics. Number one, AI RAN. It's an AI native by design. So like I said, AI RAN isn't just adding machine learning AI models, small, medium, large, to the existing workflow. It is about re-architecting the RAN, radio access network, so that AI machine learning can drive the core functions and enabling the network to become more truly a customer aware, context aware, application aware, and adaptive and the data driven and etc. The second key characteristic is the autonomicity. So in other words, self-X capability, self-healing, self-configuring, self-optimizing, self-protecting. So with thanks to the recent advancement of the AI technology, now it's feasible. Previously, it wasn't possible. Now we started to see we can develop something like this. So this means the network can be proactively respond to changes in traffic and fault and interferences without manual intervention, therefore dramatically improving operational efficiency, therefore cutting down the TCO. And third one, I would say it's a multi-purpose platform. So let me finish this and then I will stop.
Yeah.
So it's a multi-purpose platform. As Gaby already mentioned, we are driving both telco and non-telco workload, for example, AI, LLM, edge inferencing, edge computing, and etc. So this is a new avenues. Of course, there was a previous attempt, mobile edge computing, but the key difference is, it's just a traditional adoption of traditional computing rather than the AI focused, workload focused computing platform. That's the one big difference. So this time we have a much better chance than the previous trial with the mobile edge computing.
Ignacio, briefly, your perspective on the big picture for the degree of game changing this could be for telcos?
I mean, to be very very clear, imagine 10 years ago talking about Red Hat about telecommunication. Maybe it's not the case, right? So my point is, in the last 10 years, the telecommunications has changed. The sector has changed a lot in order to open the door to new technologies that they can help to evolve these networks. And as Alex was mentioning right now, this is about not having silos like networks. It's about putting all together, to combine all together to get the most. Edge computing could be RAN connectivity could be. That's the main change that I can see now. Chris.
Okay. Well, look, I want to start with the cost first and the sustainability. We know GPUs are very expensive. We also know that they use, an AI uses a very significant amount of power to do something which, if you're using Google or other search engines, use a fraction of the amount. So given this, the talk about driving network efficiency, costs down, sustainability, what needs to be true for AI RAN to achieve that? Because the input costs of GPUs and the power consumption look very high. So what, based on your thinking, has to happen for this efficiency to be true?
If I may, I'm gonna be very very clear here, right? So what we need, so the technology is gonna evolve, and pricing is gonna drop. That's what is happening with technology in every single cycle, right? Maybe trying to compare these, we need to find a DeepSeek approach to see how we can get more efficient in terms of how we use these models and these applications to be more, let's say, energy efficient. But at the same time, Chris, I do believe that thanks to AI at the same time and be able to control end-to-end the overall use case or the overall solution provided, we're going to be able to be more, let's say, aware. We're going to have a higher awareness about how much we are consuming and how we can drop this if it's possible. I think this is something that we are seeing. AI is helping on that in doing and taking this action nearly in real time. So I do believe in terms of technology, yes, maybe the TCO is not right now the best, but it's got a matter of time. 5 years ago, when we were talking about cloud RAN, it was very clear that the servers at that time, the cost hardware server, to find an example, they were very expensive and they were killing the cloud RAN or the open RAN TCO. We are not there yet. So we are now nearly in a like for like. It's going to be a matter of time that the same is going to happen with GPUs.
Yeah, I agree with what Ignacio just mentioned. So let me build on top of it. So there are misconceptions about the GPU consuming more energies than the traditional chips, like a CPU. And also, we need to clarify, for example, let's take an example, the massive MIMO, which is a very critical network functionalities, RAN component, the massive MIMO. So massive MIMO requires a huge parallel or matrix computations. So if you are using use the GPU for this massive MIMO beamforming and etc. complex algorithms, you can run this algorithm done very quickly than CPU. So per energies consumptions per second of GPU probably much higher than the one in CPU. But if you are able to finish the job like 1/10 of the time compared to the CPU, then the overall energy consumption actually you consume less energies than the case of CPU.
And are you
right?
testing that at the moment? Are you testing those assumptions and those trade-offs at the moment? Is that some of the things you're doing at SoftBank?
Yeah, exactly. That's why we are running this kind of a trial pilot with the partnership with the Red Hat. So some of the initial findings already, is telling us, there is a misconceptions.
Right.
And the other thing, TCO cost pricing perspective, yes. But if you are compare just one CPU chip versus one GPU, discrete chip, GPU is very expensive. But imagine the CPU can accommodate, for example, one GPU can accommodate 20 cells. But if you want to support the same number of cells, like 20 cells with the CPU, you need more than one. For example, you need the 5 or 6 CPU chips. So you have to consider how many chips are required to support a given number of cells.
That's perfect. Those are kind of that's really interesting. Those orders of magnitude, I think, are useful for people at the beginning of the journey to get some understanding of why we're not comparing apples and apples when we talk about the cost of a CPU and a GPU, or the energy consumption of a CPU versus a GPU. I think the other thing that people are interested in is, a lot of talk about running enterprise workloads. And AI obviously is huge at the moment in terms of large language models, and there's talk about inferencing bleeding out to the edge. We're already seeing a lot of compute, obviously, on-prem. We've got regional data centers are exploding, as well as the hyperscale data centers. What are the specific use cases that you see where having AI deep in the network at the RAN is going to be useful for running enterprise workloads?
Ignacio, you want to go first?
Yes, I think we are seeing already. If you talk about visual analytics, in many cases you need to have very, very low latency. If you're talking about robots or you're talking about self-driving vehicles, it's for sure that latency is gonna matter. And having this, not the whole, but partially out of the AI capability as closer as possible is gonna help to deal with that. That's something that is there. Maybe the question mark is when we're gonna reach this as a massive number of use cases deployed worldwide. But in terms of the use cases, Chris, they are there already.
Yeah. I mean, same on my side. It's mobile robots. I mean, we are expecting the humanoid robot will appear in the factories sooner or later. And assuming that, you should be able to use more edgy computing based inferencing services with the lowest connectivities. So that's the best solution, and that I believe is the only solution. Not only the best solution, but it's going to be the only solution, because any latency for the mobile robot matters. It's a critical. It's a mission critical. Whatever you miss something, and then you're going to be in trouble. So that's the most critical use cases. And on top, a lot of employees will start to use like a ChatGPT, like voice interface based assistant. At the same time, it's the same. They will need extremely low latency, context aware, and data protected, privacy protected, chatbot services. And we are talking about voice, right? Not just the text. So in voice conversation, once again, and every millisecond counts.
And there's been a question here specifically about, how low is the low latency you think you'd achieve at the RAN compared to what you get further back in the network at the regional data center, for example? What's the differential? And will that open up use cases that you can't then resolve through just having edge compute at regional data centers, which are seeing a massive build out at the moment?
Also depends, I guess, with it's not the same US if you compare maybe with the Netherlands in terms of the countryside, right? And probably there are certain countries that the first choice, the first step will be a couple of edge data center nationwide, because it's enough in terms of latency. And when you were talking about what latency in terms of the application should consider, well, it depends on the use case. If you are talking about using some virtual Googles with virtual reality, we're talking about 15 milliseconds. Beyond that, you're gonna feel dizzy if the latency is higher. But it depends. My point is, it's not that we need to start since day one with nationwide coverage. You need to start with the use cases. You need to see, and you need to understand what is the real latency that you need to achieve there. And probably, yes, at the beginning with 1-2 edge data center is going to be enough for covering this use case. And the way that you're going to grow is probably for capacity. You need to expand. You need to expand because you have more customers, and you don't want to send over the traffic all over your network. So probably in terms of being more efficient is more efficient. Start deploying this compute capacity closer to your customer.
If I build on top, as far as the latency concerns, yes, distance matters, but that's not the only, factors. There are many other factors. For example, computation overhead. If you run the, very heavy models on the centralized data center, the computational latency will occur because they have to process so many inferencing requests from everywhere, right? So therefore, computational latency will affect on the overall latency. And on top, unlike an enterprise on-prem environment, you need to think about the security overhead. For example, firewalls and air-gapped security systems. So all this additional firewall and security system will also introduce additional latencies. So if you bring your computations right next to your environment on-prem, then you don't need to concern about all this unpredictable latencies. So you can get rid of these unpredictable latencies.
Mm. Thank you. Now, we've had quite a few questions. I'm going to try and get to some of them. Some of them very practical. So, Alex, a couple of people asked, can they join the AI RAN Alliance? I assume they work for a technology company. If they want to do that, or they want their organization to do that, what's the process?
It's just simple. You just go to the website ai-ran.org, and you can get the information how to join. And yeah, there is a membership information.
One of the questions here from Simone, and I don't know whether he's referring to, I think he's referring to the IRAN Alliance. He says, EMEA is behind in adopting, also because European operators are not keen on accepting the contractual conditions of AI RAN, which seem to be American-centric. I'm curious to know what Alex thinks about the entry barrier to European operators, and if AI RAN would be interested to review their rules to better accommodate the European mindset. I don't know what he's referring to there, and I don't know whether that's AI RAN Alliance or something else.
I don't believe there is any entrance barriers, other than like for example, the sovereign, AI data center and etc. Sovereignty is one probably an issue, in Europe because the government required, you have to build a sovereign AI data center.
Yeah.
But rather than utilizing the, API cores.
If I may also, Alex, something that we need to check also is what are going to be the security criteria that the different national security standards or organization are setting up here, right? Because one of the things that we are seeing is they want to have everything airtight in terms of security. So we need to explain so much how we can measure, how we can make sure that everything is secure. So I think it's one of the angles that from the AI RAN Alliance they need to address, which is about security when it comes to be compliant with the regulation country by country. And here in Europe, leaving that the regulation country by country on that.
Well, we've had a question here about how can AI RAN reassure interoperability within multi-vendor networks without dependence on open standards. Can you talk a little bit about that?
It's a little bit tricky question. So without depending on open standard.
I guess you're saying you're not a standards body, and I think they're picking up and going, well, without any standards, how will AI RAN work?
Oh, okay. Don't get me wrong. We are not. We declare we are not the standard body. That doesn't mean that we are not respecting or relying on any standard at all. So we are just counting on other SDO to do the job, to develop the standard, open platform standard, especially the ORAN Alliance, and now followed by 3GPP. So we are fully
complementary to them. Okay.
Yeah.
Okay. No, I think that's clear. I think I'm just having a look through some of the other ones here. Because there's an awful lot. Well, this is an interesting question. They're saying, suppose I'm a researcher at a telecom vendor. A typical workflow is research, then goes to patenting, goes to standardization, goes to product development. What exactly should pre-standardization activities fit into this process? I think they're asking, where does the AI RAN Alliance fit into their process? Where's the relevance of their process, which is research, patenting, standardization? Where would you be involved in that and add value to their process?
If I look at the this the technology life cycles, it comprises of 5 steps. Initial research and standard. Of course, with the patent filing and the standardizations and testing and interoperability testing, and then commercial acceptance testing, and then commercial deployment. So AI RAN Alliance, our focus is, pre-standardization, in this case, research, and do the prototyping and proof of concept, and showcasing at the, for example, Mobile World Congress, and proving that, this makes sense. And then after the standardization, we do the reference implementation, testing, validation, and deliver the blueprints. And then we, together with the operator members, we figure out how to bring it to the production system and then deployment.
Okay, that makes sense. There's a question here. I think this might be particularly relevant for you, Ignacio. It says Kubernetes is defined as an orchestrator for, I think there's container-based apps. So what exactly is the SoftBank orchestrator, and how does that interface with Kubernetes? Because in your diagram, you showed that, and I think maybe you can both speak to that.
At the end of the day, like another orchestrator, so the SoftBank orchestrator with a set of APIs is connected to our management platform in order to manage and control. So yes, it's based mainly in Kubernetes APIs, as was mentioned before. And there's no any other secret source there. And correct me if I'm wrong, Alex, but I don't think that the SoftBank orchestrator is very different compared with others. We are not implementing, maybe going back to the Oran Alliance, O2 interface. Right now, we are not working on that at that level, but right now the idea is having these two API, Kubernetes APIs, communication between the orchestrator and our own management layer at the containers to measure this Kubernetes platform.
So in our SoftBank orchestrator, we have a very specific recipe. So how to collect the data, how to understand, analyze the data, and how to figure out what would be the best next resource allocations. So that's the recipes that we have in our orchestrator. And then our orchestrator is interworking with what Red Hat's been providing, and also it's running on top of Red Hat COS, container as a service, which is a Kubernetes.
Brilliant. Thank you. I'm conscious of time. We've got a lot of questions. Some of them are very specific to each of you. Some of them, I think, to your point, Alex, can be answered by going on your website, or indeed on the Red Hat website. But others will probably need a response. So we'll send the panelists some of those questions and filter those, and then make those available to all participants along with the presentation. It just is, I think, my job to thank both Ignacio and Alex, and of course Gabby, who presented earlier, and to Red Hat for their sponsorship, and most of all perhaps to the attendees for your valuable time. As I say, we will follow up. We'll make the recording available and seek to answer as many of the questions, which were a little overwhelming in number this time. But thank you for that. It does show there is a thirst for knowledge. Some of them are very specific and probably beyond my technical capabilities. So I'll be pushing them in your direction, pronto, Ignacio and Alex. So thank you, everyone, and look forward to joining you again soon.